Have you ever stopped to think about where your photos actually go when you upload them to the cloud? Like, you tap a button on your iPhone and boom, your entire camera roll is backed up. But backed up where exactly? Everyone talks about the cloud like it's this magical, invisible place floating above us. But here's what nobody tells you. The cloud isn't in the sky at all. It's sitting in massive warehouses scattered across the country using enough electricity to power entire cities. And the way it actually works, it's way more fascinating than you think. In the next 15 minutes, you're going to understand exactly how cloud storage actually functions behind the scenes. And once you see it, you'll never think about saving a file the same way again. Here's what's really happening every single day. You're scrolling through your phone at Starbucks and your storage is full. Again, so you delete a bunch of apps you never use, clear out some old texts, and then you see that notification, upgrade to iCloud for more storage. $2 a month, easy decision. You tap yes, and suddenly you've got 50 gigabytes of space. Problem solved, right? But think about it this way. Where did that space come from? Like, your phone didn't suddenly grow a bigger hard drive. Apple didn't mail you a USB stick. So what actually happened when you paid those $2? Your data has to be going somewhere physical. It has to exist in reality, taking up actual space, using real electricity, sitting on actual hardware. But where? Everyone tells you it's in the cloud, and then they move on like that explains anything. But that's not what actually happens. What really happens is your photo of your dog gets chopped into pieces, encrypted, copied multiple times, and shipped to a building the size of 3 football fields in Iowa, or Virginia, or Oregon, and that building is absolutely packed with computers that never, ever turn off. Here's what most people don't realize. When you save something to Google Drive, or Dropbox, or iCloud, you're not storing it in one place. You're storing it in like 5 places simultaneously. And this matters because the entire internet, everything you've ever uploaded, every Netflix show, every email you've ever sent, all of it is sitting on hard drives in these massive warehouses. We call them data centers. And there are thousands of them across America, quietly humming away, keeping your stuff safe. It's not magic. It's just really, really clever engineering that nobody ever explains properly. And this matters because you're trusting these systems with literally everything. Your family photos, your tax documents, that novel you've been writing for 3 years. All of it could vanish tomorrow if you don't understand how it actually works. It's not just about technology. It's about whether your memories are actually safe or if you're one server failure away from losing everything that matters. So here's how cloud storage actually works. And I'm going to break this down so clearly that you'll wonder why nobody ever explained it this simply before. When you upload a file to the cloud, something pretty wild happens immediately. Your computer doesn't just send your file to one location and call it a day. Instead, it does something called chunking. Think of it like this. Imagine you've got a huge pizza and you need to mail it to your friend across the country. You wouldn't try to ship the entire pizza in one piece, right? You'd slice it up, put each slice in its own container, and send them separately. That way, if one package gets lost, you haven't lost the whole pizza. That's exactly what happens to your files. Your computer takes that video of your kid's birthday party, let's say it's 2 gigabytes, and it chops it into thousands of tiny chunks. Each chunk is maybe 4 megabytes. Then each chunk gets encrypted, which means it gets scrambled into gibberish that only your account can unscramble. And here's the clever part. Those chunks don't all go to the same place. They get scattered across multiple data centers in different states. Maybe some chunks end up in Iowa, some in Oregon, some in Virginia. Why would they do this? Because it's basically impossible to lose your file this way. If a tornado takes out the data center in Iowa, your file is still safe because the other chunks are sitting in Oregon and Virginia. It's like hiding pieces of a treasure map in different locations. You'd need to destroy all the locations simultaneously to lose the treasure map. But here's where it gets really interesting. Those chunks don't just get stored once, they get copied multiple times. This is called redundancy, and it's the reason cloud storage actually works. Let's say you upload a photo to Google Photos. Google doesn't just save one copy of that photo. They save 3 copies, sometimes 5, Each copy lives in a different data center, on different hardware, managed by different systems. Think about it like this. Remember when you were a kid and you had that one Pokemon card that was super rare? You probably kept it in a special binder, maybe in a protective sleeve, but if your house burned down, that card would be gone forever. Now imagine if every time you got a rare card, exact copies of it magically appeared in your best friend's house, your cousin's house, and your grandma's house. Even if your house burned down, you'd still have that card safe in 3 other locations. That's redundancy. This matters because hard drives fail all the time, like constantly. In a data center with 10,000 hard drives, several of them are dying right now as you're reading this. But you never notice because the moment one drive fails, the system automatically pulls your data from one of the backup copies and creates a new copy on a different drive. It happens in seconds. You never even know it occurred. Now, this next pattern is particularly sneaky because most people never think about it. When you delete something from the cloud, it doesn't actually disappear, not right away. This is what I call the ghost file phenomenon. Your file becomes invisible to you, but it's still sitting on those servers, sometimes for months. Here's what's actually happening behind the scenes. When you delete a photo from iCloud, Apple doesn't immediately erase it from their servers. That would be inefficient. Instead, they just mark it as deleted in their database. Your account can't see it anymore, but the file itself is still there, taking up space on a hard drive in some data center. Eventually, usually after 30 days, the system will actually erase it. But until then, it's just floating in digital limbo. Why does this matter? Because nothing is ever really gone as quickly as you think. That embarrassing photo you deleted, it's still technically on a server somewhere for a few weeks. That document with your social security number that you thought you erased, still there, not accessible to you, but definitely still existing in physical form on a hard drive somewhere in North Carolina. And if you think that's wild, check this out. Cloud companies use something called deduplication to save massive amounts of space. Here's how it works. Let's say 5 million people all upload the exact same cat meme to Dropbox. Dropbox doesn't actually store 5 million copies of that meme. They store one copy and then they just create 5 million pointers that say this person's account has access to that one file. It's like a library system. The library doesn't buy a separate copy of Harry Potter for every person who wants to read it. They buy one copy and they keep track of who's checked it out. Same idea. If you and your friend both upload the same PDF to Google Drive, Google only stores it once, but both your accounts can access it. This saves absurd amounts of space. We're talking billions of dollars in server costs. But here's what makes this even more surprising. The way your files actually get to these data centers isn't what you think. When you hit upload on your laptop at home, your file doesn't travel through the air to some satellite and then beam down to a server. It travels through cables. Physical cables made of glass fibers buried underground, running along highways and under oceans. Your file gets converted into pulses of light. Literally. Light traveling through these fiber optic cables at ridiculous speeds. Those light pulses carry your data across the country or across the world, bouncing through dozens of routers and switches until they finally reach the data center where they'll be stored. The whole trip might take a few seconds. But it's not happening wirelessly. It's happening through a massive physical network of cables that connect pretty much everything on Earth. This connects to something even deeper about how the internet actually works. See, we think of the cloud as this ethereal, virtual space, but it's intensely physical. Those data centers use insane amounts of electricity. A single large data center can use as much power as 40,000 homes. And they generate so much heat from all those computers running 24/7 that they need industrial cooling systems just to keep from melting down. Some data centers pump in millions of gallons of water every day just for cooling. Google has a data center in Oregon that sits right next to the Columbia River because they need constant access to water for cooling. Facebook has one in Sweden because the cold climate means they spend less on air conditioning. Amazon has data centers scattered across like 25 different cities because they need to be geographically close to their customers. The closer the data center is to you, the faster your files load. That's why Netflix probably has your favorite show stored on a server within 100 miles of your house. And here's the uncomfortable truth that nobody wants to admit. The cloud isn't unlimited. We talk about unlimited storage like it's actually infinite, but it's not. Every single file you upload takes up physical space on a physical hard drive, in a physical building. And those buildings have limits. The only reason companies can offer unlimited storage is because most people don't actually use that much space. They're betting that the average person will store way less than their fair share, which subsidizes the few people who store tons of data. It's like an all-you-can-eat buffet. The restaurant isn't actually expecting you to eat $50 worth of shrimp. They're expecting most people to eat $10 worth and get full, which means the restaurant still makes money overall. But if everyone actually ate as much as they physically could, the buffet would go bankrupt. Same thing with cloud storage. What's actually happening is this. Cloud companies are playing a giant game of statistics and probability. They know that if they give 1 million people unlimited storage, maybe only 10,000 of them will actually upload terabytes of data. The other 990,000 will upload a few gigabytes and forget about it. So the company only needs to build enough physical server space to handle the 10,000 heavy users, not all million. And this works until it doesn't. Remember when Amazon Web Services went down in 2017? Half the internet stopped working, Netflix crashed, Spotify stopped playing music, a huge chunk of websites just displayed error messages. Why? Because one data center in Virginia had a power failure, and way too many companies had all their data stored in that one location. They hadn't spread it out enough. This isn't because Amazon is bad at their job. It's because the cloud has physical limitations that we pretend don't exist. This is why you occasionally see companies like Google or Microsoft quietly reduce their unlimited storage offerings or add restrictions. They realized they miscalculated how much data people would actually store, and their servers are filling up faster than expected. It's not unlimited. It never was. It's just a really big number that they hoped you wouldn't reach. Let me tell you about 2 different people who learned this lesson in very different ways. Let's talk about Marcus. Marcus is a wedding photographer in Austin. He shoots about 30 weddings a year, and each wedding generates something like 50 gigabytes of photos and videos. That's over a terabyte of data every year. And Marcus, being a smart guy, uploads everything to the cloud. Google Drive, mainly. He pays $15 a month for 2 terabytes of storage, and he figures he's set for life. But here's what Marcus doesn't realize. He's putting all his eggs in one basket. Everything, every wedding he's ever shot, every client's photos, every backup, all of it lives in one Google account. And Marcus assumes that because it's Google, it's safe forever. He doesn't keep local backups. Why would he? It's in the cloud. Google's not going anywhere. Then something happens. Marcus gets an email from Google saying his account has been flagged for suspicious activity and temporarily suspended. Maybe someone tried to hack it. Maybe Google's algorithm made a mistake, doesn't matter. The point is, Marcus can't access any of his files. He's got a wedding to deliver in 2 days, and all the photos are locked behind a suspended account. Marcus spends 3 days on the phone with Google support, slowly losing his mind, before they finally restore his account. But during those 3 days, he couldn't work. He couldn't deliver photos to his clients, he couldn't access anything, and the whole time, his files were sitting safely on servers in Oregon, perfectly intact, just completely inaccessible to him. Now compare that to Jen. Jen's a graphic designer in Brooklyn, and she also stores everything in the cloud. But Jen understands something Marcus didn't. She uses what's called the 3-2-1 backup rule. 3 copies of everything, 2 different types of storage, 1 copy off-site. So Jen keeps her working files on her laptop's hard drive. That's copy number 1. She backs everything up to an external hard drive sitting on her desk. That's copy number 2. And then she uploads everything to Dropbox. That's copy number 3. Plus, she's got 2 different types of storage, physical drives and cloud, and 1 copy is technically off-site because Dropbox's servers aren't in her apartment. When Jen's laptop died last year, like completely bricked, wouldn't even turn on, she wasn't stressed at all. She bought a new laptop, plugged in her external hard drive, copied everything over, and was working again within an hour. The cloud was there as a safety net, but she didn't need it because she had local backups. Notice how both of them trusted the cloud, but only one of them understood the system? Marcus treated the cloud like a magic safety box that could never fail. Jen treated it like one part of a larger strategy, and when things went wrong, which they always eventually do, Jen was fine and Marcus was panicking. Here's what most people don't realize about all of this. It's not actually about whether the cloud is safe or reliable. It's about understanding that the cloud is just someone else's computer. That's literally all it is. When you store something in the cloud, you're storing it on a hard drive that belongs to Apple or Google or Microsoft. And that hard drive exists in a building somewhere in America, connected to the internet through physical cables, powered by electricity from the local power grid, cooled by water from a nearby river. The people who succeed with cloud storage don't have unlimited trust in technology. They understand the system behind the magic trick. They know their files are being chunked, encrypted, duplicated, and scattered across multiple locations. They know that redundancy is what makes it work. They know that nothing is ever truly deleted immediately. And most importantly, they know that the cloud is one tool in a toolbox, not the only tool. It's not about being paranoid. It's about understanding the physical reality underneath the abstraction. Once you see the cloud as a network of buildings full of hard drives instead of as magic invisible storage, everything changes. You start thinking about backups differently. You start understanding why some services are faster than others. You start realizing why your files sometimes take forever to upload. So here's what we've uncovered. The cloud isn't floating above you. It's sitting in warehouses across the country, using enormous amounts of electricity and water, storing your files in encrypted chunks scattered across multiple servers. Remember how your files get chopped into pieces, plus how those pieces get copied and stored in different locations, plus how nothing ever really gets deleted immediately? This all connects to the fact that cloud storage is deeply physical, not magical. The question isn't whether you should trust the cloud. The question is whether you'll understand how it actually works so you can use it intelligently. Because now you know your files aren't in the sky. They're in Iowa and Oregon and Virginia, humming away on servers that might be closer to your house than you think. You can't unknow it. So next time you tap that button to upload something to iCloud, ask yourself, do I understand where this is actually going? Because once you see the cloud as someone else's computer instead of digital magic, everything looks different. And that might be the most valuable thing you learn all week.